And that's it. For the bank application, I don't need the CCV code. I don't need your name. I just need the credit card number. And I need, of course, to make sure that you are inside this particular bank. But guess what? The credit card always have a fancy logo of the bank. At least on mine there is. So it's obvious to know which bank I'm in. So eventually you get very detailed credit card bills of the guy, and that's really nice. This is you can have quite a good fun with this. By the way, for those decision makers out there, if you have a chance to make a decision like this, if you could please find something else than credit card, because that's the worst way payment method ever. I mean, there's never been any security on it, and there never will. It's just impossible. It's just a number. How do you want to secure a number? So if some of you are in meetings of very high power people into banks, to come up with new standards and stuff, please do something for that credit card. We want to get rid of it. We really want. So how do you protect against read logic flows? Well, it's very straightforward. Again, this is all simple, but you're not doing it. You're not doing it. As simple as this. All you have to do is you keep as many parameters as you can on your server. Why do you want to pass all and each and every small parameter to the client? First, it's going to be slower because the parameters go back and forth. Second, you give a chance to the hacker to play with it. You give him a grip, basically. Pass them by reference instead of passing them by value. Like this, if I modify the reference, it will be an invalid reference, and that's it. And I can't modify it, and I will be screwed. And of course, you verify that it's authorized. You do verify from each and every transaction. Okay? It's not being done. I know it sounds simple. It is simple, but it's boring. That's why I'm not doing development anymore. What do you think? It's boring development, I know, but it's got to be done. So now the interesting attack. I mean, interesting. Everybody wants to steal money. So that's the way you do it now. Is with those write logic flows. Write logic flows is exactly the opposite. We don't read, we write. So write in that sense will be whatever that leaves a trace. So a transaction is a write. When I modify your personal information, whatever I do that leaves a trace, that modifies something, it's going to be a write. Again, applications are stupid. They just do what they are told. So you just told them to perform the fraud for you. And again, supposedly it will check, but it won't. It just never does. And what it does, it never does properly. So we'll still find the flow and we'll still bang on it. So of course, this one everybody has tried, even some of my colleagues who are not specialized into that kind of stuff. This is definitely the prime suspect. When you see something like this, your hands are itchy and you're going to try something like that. Everybody has in the IT security industry. Instead of forwarding a message whereby the money goes from my account to my friend, I will change the from field to the victim going to my friend, or to a second of my account. So of course this is a prime suspect as far as logic flows are concerned, because that's the very nature of that functionality. What you have to remember with all those logic flows is the more features your bank application has, or any other application for that matter. This is just bank because, well, you steal money, it's nicer. But every other web application are the same, when it comes to logic flows. The more features they have, the more easy it's going to be for us to find one that we can abuse in a way or another. So this one to abuse is very straightforward. Of course, I steal money right away. But here I'm still not stealing from the bank. Imagine, I have to find a poor soul from which I will steal money. Sometimes you won't steal from the bank if you don't like the bank. So another one, cashier order. Again, I have very limited financial knowledge. Until recently, a cashier order I never received any. But we stole lots and lots of money using that on the other hand. By the way, before I continue, don't be scared. When I say we stole and so on, we're totally legal. I don't want the police to storm and everything. This is whatever we've seen when we perform application assessments before they go live. I may have forgotten to say that. So don't worry, don't go out and close your account right away with the bank. Usually they do check. Well, if it's not checked, then now you know what you're going to find into it. But typically it is checked, and typically this is what you find. So a cash order here again, very simple. You just take it from help yourself from the victim funds. Buying share at discounted price. I love that because I don't know how to buy share properly. So I don't know anything about that. And they usually do it in C. And again, they don't know how to code in C. So that's where you get your buffer overflow. Again, I was pretty quick on this. Everybody know about those. They are not so, but they are still there in banks though, although they are rare. Weak script, my personal favorite. It's amazing the amount of crap you can find on bank servers these days, on application servers. You have some scripts that don't even compile. You have some that don't even check that the parameters that they need are there in the first place. You have verbose error messages. Some will crash the whole server if you just call them without parameter. And they're easy to find, you know. We don't do black box. We have 1 to 2 weeks to audit an application that the guys wrote in 3 years. We're not going to play hide and seek. We're just going to get the EAR file or the WAR file or the whole web root file, an archive and so on, and we'll have all the files inside there. All we'll do is we'll build a bunch of URLs to encompass them all and call them one by one without parameter and see how they survive. You'd be surprised that at least half of the scripts will die with a horrible error message or will crash your whole server or fancy stuff like this. So it means the developers haven't even done the most basic job, which is to check that I receive exactly what I'm expecting. So it's extremely quick to test, although it's monkey job. This gives you a pretty quick look and feel, you know, of how crappy the application is. And most of the time it's not how good, but how crappy it is. You'll see later when we see about the logic flows that you typically find in those applications. Denial of service, well, you know, if you can't steal from it, you can still trash it. If you really don't like the bank. No, I have nothing against bank, don't worry. So the common one, again, I'll be quick, it's not so interesting, this part. Recursive operation, you're supposed to call another script, but you manage to call yourself, so you end up in an endless loop, and you will effectively kill the machine, or run out of threads, or things like this. Extremely long timeout, this is in pretty much every application. You force the application to do a slightly or a lot longer than usual operation, and you do it in parallel, and then you will use up all the threads of the application server. So again, the application will be totally unresponsive to anybody else. Blocking operation, one of my favorites. Sometimes server-side scripts are stupid enough to read files that you tell them to read. In which case, I've got plenty of files that are either blocking on Windows or URL that are blocking as well. So eventually you'll use up all the threads, and again it will be DOS, and of course buffer overflow. Since, like I said, all the object-oriented languages don't have buffer overflow, Java doesn't have any. So if you find one on a Java application, it means they got some C code somewhere. And the C code, the magic stuff of it is that it won't get an exception. It will just get a segmentation violation, or the equivalent signal on Windows, and it's going to crash the whole app server, which is a lot nicer. Right, now the interesting frauds, the one that, as far as banks are concerned, are interesting. For us, you will see, it's very straightforward to apply. All these I will not explain exactly in details how do we do it. I'll make it sound easier. Some of it is very easy, some of it is slightly less easy. The goal is to show you the strategy that we use to steal money. Some of it is trivial, some is slightly less. So you will see, more or less it will sound trivial, and yet it is there. Because I'll show you later with statistics just how often it is there. Right, so first we introduce a read logic flow. What's a read logic flow? It's very simple. It's when you read stuff you're not supposed to have access to. On a bank application, that'll be I don't have access to John account information. I just have access to my own. And remember, application and web-based application are very simple. They just perform what the web client asks them to do. So you just ask for the forbidden information, and that's it. Of course, the application is supposed to check and tell you, no, I'm sorry, you're not authorized. But it never does. It just never does, because people just click, 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 and the application exists and works. So how would they know? So there is a few kind of, this is a slightly more technical piece of advice for web developers out there. If you ever pass all the parameters that I need for the request on the command line, I mean on the either the get request or the post request. In other words, if all the parameters are in the hand of the attacker, it is almost confirmed we'll find a way to whack you. We might not whack you direct, it might take some time, we might find some weird Hulu way, but we'll find it. The goal is basically to limit the number of parameters that the client passed to the server. Because like this you limit your visibility, as in the attacker can only touch what goes between his machine and the server. So of course some of them are slightly better. They do check, you know. And in which case we're left with only a harder vulnerability whereby we manage to modify stuff server side. There were a few flaws like this in the past, but they're pretty rare. So, in a nutshell, what we do is that on top, it's always the same on all the schematics, you will see. On top is what we do on the web interface as a normal user, you know. So, right here, typically, I would want to check my own transaction history. And in fact, what I do is I submit the request, catch it with my proxy, and on my proxy, I replace what you guys can see over there in red. Again, this is in plain English, this is simplified. When you see one parameter here for the application, it might be 10 of them, and some might have to be brute forced and stuff, so it's sometimes a bit harder. But like I explained earlier on, all we do is to ask for the prohibited information. Now I'm asking the transaction history of the victim. It's either the application checks and refuses, or it doesn't, which most of the time it doesn't, and it will give it to me. Spying on competitor bill payments is the same. The message is slightly bigger. Look at the message on the right mostly. Instead of looking at our own bill, which has our own bill ID, we look at the one of the victim. This one is slightly harder because typically you would have to know the bill ID, which is usually a reference on the database, and you may have to brute force that one. But again, brute force, you can brute force all you want because there is no error logging whatsoever. So and when there is an error logging, sometimes it's just all the exceptions that are put into a flat file. So at the end of the day, when you have 2 million exceptions in a flat file, good luck with your forensics. Just good luck. I'll be gone a long time ago with all your money. Banking messages are those small messages, you know, when you do a transaction, he will tell you, oh, your telegraphic transfer failed, or it succeeded, or you didn't have enough money last minute to transform it. All sorts of little basic information, but that could be quite interesting. So it's also possible to read other people's banking messages. This one is extremely straightforward, all the implementation we've seen, because every time they use an incremented message ID. So you can read everybody's message, just increment one by one and ask for the next message, next message, next message. If you get a message that doesn't exist, it means you reach the last message in the database. So it's extremely quick. You start with message 1 and go all the way up. That's a personal favorite as well. It's always nice to know what your boss spends on, or what your prime minister what spends on. Depends if you're into politics or not. I'm not, so I'm more interested in what the boss spends on. You have to have the card number most of the time, but don't go and think that, oh, it's safe, you know, card number, nobody knows it. Bollocks. Everybody got the card number of everybody. It's not difficult. All I have to do is to go for a beer with you. You're gonna buy me a beer, and I will see your card number. You know, it's only 4 times 4 digits. I think I can remember that. And you know, that's all I need. This and your name, and maybe the CCV code behind, and that's it. For the bank application, I don't need the CCV code. I don't need your name. I just need the credit card number. And I need, of course, to make sure that you are inside this particular bank. But guess what? The credit card always have a fancy logo of the bank. At least on mine there is. So it's obvious to know which bank I'm in. So eventually you'll get very detailed credit card bills of the guy, and that's really nice. This is you can have quite a good fun with this. By the way, for those decision makers out there, if you have a chance to make a decision like this, if you could please find something else than credit card, because that's the worst way payment method ever. I mean, there's never been any security on it, and there never will. It's just impossible. It's just a number. How do you want to secure a number? So if some of you are in meetings of very high power people